I'm going to show you instructions in a cyan box like this. So MOV at the front here this is the move family of instructions, and the X at the end means I use a suffix like B or Q or so on. The move instruction takes a source and a destination, and these things are operands in the way that we've just talked about. You can't have every possible combination of source and destination operation shape. There's a set that work, and fortunately in this class we're mostly not writing them, we're just reading them, so we're not concerned with what's possible, just what we can read. For example, if I have move B, $hex F, and then RBX in parentheses, what this will mean is the move B says we're going to copy something, and we're copying a byte specifically because of the B at the end. The $0xF means we're copying literally the value hex F, or 15. Now that has to be a value that fits in a byte, otherwise this wouldn't make sense. Okay. And where we're copying it to is you take the address that's in RBX, and we're going to put it in that place in memory. Here's another example. This says move W %AX %RSP. So in this case we are copying 2 bytes because of the W. We're copying it from the register %AX. There's a little redundancy here. The %AX is a word size view of the register. It wouldn't make sense to write EAX or RAX here. It only makes sense to write %AX. And then we're copying it into memory. We're using RSP here, right? We're using the whole 64 bits of RSP to identify an address into memory, even though all we're writing there is 2 bytes, right? So the 2 bytes happens on the memory side. If I left off the parentheses around RSP, that would mean move the value from AX into the RSP register. It also wouldn't be well formed. I would need to use the 2-byte name for RSP instead of the 8-byte version that I have. Okay, so move is what we use for generally moving a value from memory to a register, among registers, from registers to memory, or literal values into registers as well. Here's another example, a couple of examples, push and pop. These are data movement, but also adjusting the values of registers. So it's combining an adjustment of RSP with a kind of move. It's doing 2 moves effectively. So push L means take the address in EBP, and the L part means that we're copying 4 bytes. The push L part, since it's 4 bytes that we're pushing onto the stack is represented by RSP, and the stack grows down, so we're going to decrement it by 4 bytes. And we're going to copy it from EBP. Again, the EBP is consistent with the L, right? It's the 4-byte view of that register. We're taking those 4 bytes out of that register, putting it onto the stack, as pointed to by the new RSP after we've decremented it. Pop is the other way around. This is a pop Q, so we're going to copy the 8 bytes into RAX. Again, that register name is consistent with the Q. Right? And where do we get them from? Pop implicitly gets it from the address, the place in memory as referenced by the value of RSP, and then as the last thing, after we fetch that value out, then we increment RSP by 8 bytes. All right, in other words, pop it off the stack.